on your calculator. That is probably also another hurdle that we sometimes have. Okay, so I know I sound like a broken record, but what I do is I look at this and I'm like, I'm gonna figure out the max, the min, and the period right off the bat, because that's gonna help me with my graph. So I just do that on the side here. Max is 20 plus 20, so that's 40. The mid is actually very easy. The mid is just 20. It's always that back number there. And the min is 20 minus 20, so that's 0. So this thing gets as low as 0, as high as 40. I figure out the period as well. And I think I had this one ready to go here, so I'm just going to go off my key. Thought I did. No? I guess I didn't. Well, there it is. Finally. That gives me, if that's 62.83 seconds. This is the wrong one. Never mind. It looked the same at the beginning, but it's so 2 pi. I'll figure it out. 125.66. So that is, watch this. This is probably something that, this is the scale is the issue here. It can still be done, but the period is 0.05. What's up with that, right? That is not that is a very, very small number, which will affect your screen on the calculator. So let's try this. I typed this in already. I graphed it. Ooh, this actually works. Did I make a mistake? No, I'm good. Let's see my window. You don't see this, do you? Is that what you're seeing? Trying to figure out. It should not be the case. Did I make a mistake? So I think this is a technology problem. I think this calculator right now is getting, something is getting messed up by the period being this small. It can't handle it, okay? Do you remember, if you go to your window, do you remember what I told you to put in your X max normally? I said go 3 times whatever the period is. I think if you stick to that, you're going to be safe no matter what. Like, it's going to work for you every time. If I hit enter, then that's what your X max should be. In that case, please look, do you see how X max is 0.15? You see that? Please don't make X min like -5 or something, because then you're going to see like a lot in your negatives and just a little bit on your positive X, right? You're not going to see. So you need to scale this accordingly. So I went -0.01 and then positive is 0.15. Let's hit graph at that point. If you've done these changes, and obviously, sorry, I meant to also say y min is, I'm going to go -1. Y max, I'm going to go 45 or something, because it goes between 0 and 40. We know that. That's why I want you to read information off of your equation. That's a fail-safe method of making sure you're doing something right. So let's go hit graph. Once you've got these values in there, hit graph. And that's what you should see. Look, we're seeing 1, 2, 3 caps, which is the equivalent of 2 cycles. This is more like it. Okay? State the piston's maximum and minimum height and the period. Oh, coincidentally, I've done that already. Except for you would want to add units to it. Max would be meters. Or is it centimeters? Sorry, centimeters. The minimum height is 0 centimeters, so if labeled, so that's technically correct. 0 centimeters. And the period is what? What would the units be for the period? It's your x-axis. Seconds. Yes, in this case it's seconds. Whatever your x is labeled as. If x had been the distance in centimeters, then this would be in centimeters as well. But it is seconds. Okay? So we figured everything out right here. We've actually answered A by doing this. I would have done that regardless. The question kind of sets it up for you. B, suppose the piston operates for 1 hour. How many complete cycles does it make? Here's what I want you to do as follows, right? Number of cycles is going to be the total time divided by 1 period. Like how long it takes for 1 period to, that's 1 cycle. So if you take the total time we're talking about, you divide it by how much it takes for 1 cycle, then you're going to find out the total number of cycles. So let's figure that out. We know that 1 period is 0.05 seconds. So the top must be in seconds as well, correct? How many seconds are there in 1 hour? Let's do the math here. Yeah, 3,000. So 1 hour has 1 hour is 60 minutes. And then you know that 1 minute has 60 seconds. You get to cancel the minutes. So it's really 60 times 60, right? 3,600 seconds in 1 hour. So this is also an aside. So 3,600 is what we're going to put over here. If you divide this, you get 72,000 cycles. And remember, this is an engine, right? When an engine runs, right, the piston inside moves really, really fast, right? So it's not surprising to us that this is a big number. 72,000 ups and downs. How's that? Like 1 up and down is 1 cycle. Another up and down, right? Sorry, up, down, up is 1 cycle, I should say. And so it does that 72,000 times. Now, create a graph for 2 full cycles. This is where we get back to what we started off with. I taught you how to graph 2 cycles with the equation. So this is time in seconds. This is height in centimeters. Just label it somewhere. The Y scale is pretty simple. I would say it starts at 0. We're going to go to 40, right? So 10, 20, 30, 40. That's the highest this ever gets. But the X scale is tricky. The X scale is tricky, I'm not going to lie to you. So what I will do is this. Remember what I told you to do? How do you start a graph? I find my first min or max. Like I find both of those. So let's graph it. And in this case, if this is my starting point, the y-axis, I have a max first. So I'm going to go find it. Second trace max. Let's go to the left of it, to the right of it. And so the first max is 0.0140. And I'm going to find the first min as well. Second trace minimum. Let's go ahead and find it. To the left, then to the right. So you hit enter every time. That one is 0.04. And watch this. What would we call this when you have e to the negative anything? For us, that is 0. And it's not surprising that's the lowest we ever get to. Okay, so what should I pick for my scale? Let's think about it this way. I told you on your calculator, go 3 times the period. We ended up at 0.15, right? So I'm going to go 0.05. And then if you go up another 0.05, that's 0.10. This would be 0.15. So 0.01 is my max, right? It's right here. So I'm going to put a big dot at the 40 here. My min happens at 0.4. My min is 0. Okay. And then add a cycle to it, add a period. If you have 0.0140, right? If you add a period to that, you would be at 0.06 over here. 0.06 plus 0.05, you would be at 0.11. You go down here. This one is at 0.040. If you add 0.05 to that, you'd be at 0.09. Right there. And then we start. That's one cycle. It's 2 cycles. And then make sure you have the whatever you do, make sure your scale is consistent. If you pick a different scale than what I pick, that is fine. Just make sure you have a consistent scale. And if you need to label this, this is 0.05, right? The X difference here, I've always gone up by 0.05, which is a full period. Fun stuff, eh? I know. This one, I picked this one because I would say this is on the extreme of, you know, very small period, very tricky with low numbers. We're very comfortable, I think, with bigger numbers, going up by 100, 1,000, whatever. Here, it was actually a very small number. And I honestly will have to investigate what happened to the calculator, like why it did that, because It looked like a perfect wave. It should have been filled, the screen should have been filled with zigzags. If you zoom that far out, right, it happens so fast. I'm gonna have to investigate further, but that's why make sure you figure out the period so you know what it should be. So that's a bit, I guess, a flaw of this calculator. All right. Let's do the last one here, blast from the past. I don't know if you were able to do this. This is the counting methods, chapter 4. A password consists of 5 characters. You can have uppercase, lowercase, and digits 0 to 9, so that's 10, plus 1, 2, 3, 4 special characters. Those are your options. So this is 52, 62, 66. You have 66 characters to choose from per slot. Okay? Now, it says how many passwords will have at least one repeated character. I don't know, do you remember that? The at least, the infamous at least. You probably hated that, right? If it says at least one repetition, you want to go total, like total possible, and it's worth 2 marks. That's a dead giveaway. Minus no repetition, no repeats. You want to take away all the passwords that actually repeat. So what is the total possible? 1, 2, 3, 4, 5, right, that you're filling in. That would be 66 times 66. So you don't care. You can reuse the same ones over and over again. Minus no repeats. It's 66. You've used one. One is gone now. You're down to 65, 64, 63, 62. Just a reminder, every slot you fill in takes 1 away from the total. Sometimes students have they're okay with this, but sometimes when you have to start with a P or a Q, let's say, they go 2 in the front. Then they take 2 away to fill in the next slot. And I'm like, why? We've never done that before. A slot is a slot. The number you put on the top of the slot is how many options you have to fill it, okay? So remember that. How do you rewrite this? This is 66 to the power of 5 minus, how do you write this differently? Do you remember perms? I should get a perm, right, one of these days. 66, pick 5. Do you remember that? 66 pick 5 is the same thing as doing this. So let's see if we remember our calculator entries for this one. I'm going to go 66 to the power of 5. You know what? Yeah, I'll use that. 1, 2, 5, 2, 3, 3, 2, 5, 7, 6. Minus. You go 66. Do you remember how to get your P or your C? NCR, NPR, alpha. Now I even have to play around with it. Hold on, give me 1 second. Yeah, alpha window. There it is. So 66 pick 5. That is that. 107, 243, 1360. And so when you subtract them, and you can just copy paste on your calculator for that, we're so happy about that feature, I am at least. That's 1799,012,16. Go like this. You don't have to put those commas, but 17 million, almost 18 million passwords. The reason why I picked this one is it combines. So let's say all this question would have asked you for is how many passwords are possible, no restrictions. It would have been 66 to the power of 5. if this question had said, how many passwords are possible without repeats? This would have been it. That would have been your answer. But it adds another layer with saying how many have at least one repeated character. So that means there could be one repeated character or more. So we go total minus no repeats. Like these passwords right here have not a single repetition. So you remove them from the total to leave you with everything else, right? 1 repetition, 2 repetition, 3, 4, whatever. That's what you're left with, okay? So that's that.